Okay, so we are going to finish up section 4 or 5, day 1, and we didn't get to the last 2 problems. So to start to solve for x for this problem, we have to imagine that x has a lot going on. It's being divided by 2, it's in an exponent of e. That whole thing is subtracted from 100, there's division. So what we have to do is unpeel the layers of what's going on. And one of the easiest ways to do it, since we have a fraction over here, and we can turn 20 into a fraction, is to use the idea of cross multiply. So we can say 20 times this quantity here on the bottom has to equal 500 times 1, because the product of the means equals the product of the extremes. And then once we have this statement, we could divide both sides by 20 and get a little bit closer to knowing what x is. Now this 100 can easily get moved to the other side if we decide to subtract it, and we're left with negative e to the x over 2 equals negative 75, which means e to the x over 2 is positive 75. And so I have just isolated my exponential. So once I'm at that point, I'm going to use an inverse operation for the exponential written e to a power of x, and I'm going to use ln because that is the inverse operation for e to the power of x. And I'm going to do that to both sides so that I keep my equation in balance. So this left-hand side is going to simplify to x over 2 when the ln undoes the exponential. And on the other side, I have a number, which is the ln of 75. So my value of x is, if I multiply both sides by 2, double the ln of 75. And that is my solution, exact solution. But it's always good to get an approximate solution because you can check that. So my approximate solution is 8.635. And if I put that back into my original on the left-hand side, I want to make sure I get 20. So I have 500 divided by, I need parentheses because that's a binomial, 100 minus e to this number that I just got, 8.635 divided by 2. That's the power I want to put on e. And when I hit enter, I get just about 20. So that checks. For number 7, it's a different situation. Because when I look at the left-hand side, the first thing that I need to do is deal with the exponent, because that is isolated. I've got a quantity to an exponent. And if I want to get that exponent out, or get that x out of the exponent and pull it down in front, the easiest way to do it is with a log. And this could be the base of my log, what's in here. But that's not a really simple number to deal with, but I could simplify it. Or any old log will do if I decide to ln it. I can ln this side, even though the base is not e, and I can ln this side, ln both sides. Because what I'm trying to do is get this x to come down out of the exponent. And that property of logs that says that if you have a log of something raised to a power, that power can come down in front like a coefficient. And that's the reason the log is going to help me out here. And so I've got the ln of 2, which is a number. I got the ln of this mess, which is also a number. And I got a 12. So to solve for x, it's going to be pretty simple right now. I just need to divide this side by the 12 and that other number, and then I'll do that on this side, and the only thing left on the left will be the x, which is what I'm trying to solve for. So x should be the ln of 2 divided by 12 times the ln of that, the ln of that crazy number 1 plus 0.1 divided by 12. So that's my exact answer. Approximately, that would look like the ln of 2 divided by, I'll put parentheses around it, 12 times the ln of 1 plus 0.1 divided by 12. And that is approximately 6.96. So let's see if that works back up in the original problem. 1 plus 0.1 divided by 12 is a number. And I think that when I raise it to the 12 times 6, now I need parentheses around that so it does that first and then it raises it, I get close to the number 2. Close enough. So the reason I'm not exactly getting 2 is my rounding, but this is my exact answer for x.